Welcome back to our course on computer vision. I am Kaustav Tripathi, your instructor, and today we are going to start something new in computer vision that are called contours. Now, contours means basically boundaries or the borders of some object. So basically, why we use contours in computer vision? What are the use of contours in computer vision is like when you want to detect some object, like what that object is, you basically want to give it some kind of a boundary that I want to detect this much of an object, or you want to compare some kind of a object with another object. So you use contours to draw the boundary around that object and to compare it with the other objects. Like, and so suppose you want to match some kind of a design with other designs in your images. So how you're gonna do is you're gonna create a contour around that design, and then you're gonna check that design with the other images and other designs in other images. So that's why we use contours basically. And major example of contour is the object detection. With that we will see further how we will use contours in our object detection. Okay, so let's get on to our Spider ID and see how we are going to accomplish this thing. Okay, so here we are. This is our general basic program in which we have imported two libraries, CV2 and NumPy, and we have read this image OpenCV logo. Then we converted this image into a grayscale image with the help of a CV2 color method. Then we applied a somewhat of threshold in that image with 170, 225 as our threshold values. Also, I have applied Canny, and I have applied these two things. You don't necessarily need these two things. Sometimes you can only work with a one, sometimes without Canny. Look, we are talking about objects, edges detection. Okay, basically when we are using contours are made around the edges. I will show you how contours looks like and all. But contours are formed around the edges of some object. So if we are talking about edges, then definitely Canny comes into role because Canny defines the edges of an object, right? So we can also use Canny, and we can also use threshold to differentiate the object and its edges. That's why we are using threshold. So either you can use both, or you can use any, or you can use sometimes none. You don't sometimes don't need anything. I will show you all of these things, three things over here. And then I'm show my original image. So let me show you how the image looks like basically. Okay, this is the original image that looks like. Okay, now I'm going to use to create a contour. We use this some general method, that is cv2.find contours. So I'm gonna just do cv2.find contours function. And now this function takes some parameters, like first is a name source. Okay, second is a mode. Now there are lots of modes. Let me show you. Now these are the modes: RETR, external, tree, list, CCMP, flood fill. Now these are like you want external only contours, or you want if you are using RETR external, that means you will only find external contours, means outer boundaries only. If you are using a tree, it will give you all the boundaries. Then if you are using a list, it will create a list of all those boundaries. So these are these parameters. We are going to use tree as we are going to create all the boundaries. Then another is the method that we are going to use now. Basically, cv2 dot prox sorry chain. Yeah, these two methods, chain approx simple and chain approx none. Now these two methods are basically we use it. I will tell you what those are. Right now I'm using this chain approx none method over here. Okay, I will also explain this retrieval methods, RETR, that we say. The retrieval method, this is the approximation method. I will explain both of them, but just let's see how it's all gonna work right now. Okay, and one more thing, we are using an image over here. Actually it takes two parameters, like in the threshold it was taking two parameters. Okay, it is two variables, RET and image. In RET it was telling whether in RET it was giving the threshold value, and the image it was giving the arrays of the image. Same way here, it will also take two values. One is the contours. Okay, it will pass on all the list of contours inside of it, and it is a list. And second one is the hierarchy. Okay, it basically checks the hierarchy in what way it is taking the, finding the contours. Okay, and that is somewhat related with the retrieval method also. I will explain it later. First, let's see how it's all gonna work. Okay, now we have find out all the contours. Okay, now we want to draw those contours into our original image. So we're gonna use the method called cv2draw contours, and again it's gonna take the parameters like first is contours. Okay, wait a minute. It's gonna take the original image. We are gonna draw our contours into the original image, not the black and white image or the grayscale image, not the threshold image or the canned image. It is gonna work on the original image. We are gonna draw our contours on the original image. So we are gonna pass here original image, first parameter. Then we are gonna pass contours. Obviously our variable is contour only. So contours. Third one is contour idx. Okay, so this means index number of that contour. So if we use -1, that means it will display all the contours. If we use some other index number like 0, 1, 2, 3, then it will give the index contour of that index only. It will draw the contour of that index only. So you can play with it. Okay, then we will give the color, from which color it is going to draw the contour. So let's give it, I'm picking up any. I'm just typing random right now. Okay, and then thickness. So let's give it a thickness of 5. That's it. Okay, so this is our contours. First we have find the contours, and then we have draw the contours around those images. So it's basically like first we have find the boundaries, and then we have draw a line over those boundaries. So if I run this program, let's see what happens. You see over here, it has detected all the boundaries around it, and it has just draw over those boundaries, as you can see in this image over here. Now if I run over here, print len of contours. Okay, contours, as I told you, is a list. So if I run it, it will give me 22 contours are in that image. But basically if you see it, we are using these two methods, and that's why actually we are using this Kenny method over here. Kenny was doing what it was doing. It was detecting the edges, and if I just put a comment to it, okay, and again if I run it, now you see earlier we weren't having this outer boundary as a contour, right? And it has changed the whole game of it. Okay, I will show you how. If I just close it, you see here, now it has only detected 10 contours around there. Why? Let me show you why. Because what happens is this contour becomes a one contour, and this line goes all the way to this P, and it moves around the P, so it converted it all into a one contour. That's how it has changed the game. So, like these kind of things all happened all over this thing, and contours changed. Because earlier what was happening, it was detecting the edges, and the final boundary of the window is not an edge, so it wasn't accepting it, and it was finding giving you pure contours inside of the images. But right now what it was doing, it is taking that window boundary as a contour and creating a drawing the contour around that image. So that's why we use Canny or the thresholds. Okay, the kind of a result we need with this. Now if you see, we have how carefully it has founded the boundaries around these images. So like if you want to pick something like some green color object inside of this image, so we can find through here like this is the contour. And now let's talk about these retrieval methods. Okay, so there are basically two popular retrieval methods. One is RETR tree that we have talked about, displaying all the contours, but same thing is done also by the RETR list, this method. And if I run it, it will also give us the same result. The only difference between that is the earlier contour, the hierarchy contour works with the way of hierarchy, like from parent to child, okay, but this contour does not work with that pattern. It finds random hierarchies. Now if we apply over here RETR external, okay, and now if I run this program, okay, you are not seeing much of the difference, but if you see here, it isn't detecting this E, because E is an internal contour. It's this inside of an E, and same thing is with the inside of a O. It's an internal contour. It is not detecting it as a, the main contour. Okay, and you see the number of contours also become 11 in the this output field, you can see over here. And if I do the same thing by removing this canny over here, I'm commenting right now canny, and now if I run this program, okay, you see all of this becomes like kind of an internal contours, because this boundary is the external contour and it is covering the V, the P and all. So you see there is only one bigger contour, that is the final boundary, but this final boundary is running through V and the P, so it is not, means they are only showing, rest everything is gone, nothing is there, right? There are only two contours. Now if we talk about chain this approximation method, so let me show you something first. Let me print this, remove this len from here, and let me show you what is inside of this contour method. If you see variable explorer section, it will show you this numpy array. It's a complete list. Let me see if it is showing you complete. No, it is having a two lists. So one is 143 12 size, and there is 450712. Again, if I open it, what is in the access, you see this is inside of the contour method. Okay, wait a minute, let me go back. 158, 157, 156, 155, 154, 150 is a sequence. So what happening is, it is just picking out every single point around that contours. So if I just close these two and I just run this program over here, we don't need anything with the image, but you see this is the list of the points through which a contour is passing. Okay, these are all the points through which a contour is passing. Now that is being stored inside of a kind of up till here, that's one point, and then from here a second point starts, 01, 02 goes on up to this point. Now this is all stored in the contours. So basically what happening is, it is taking every point, but we don't want every point. Like if we are drawing a square, why do we need all the points around the square? All we need is a 4 points, so basically 2 points, okay, through which it can draw a square. But if we have 4 points, it can say, yeah, that can be a square. If it has 5 points, sometimes it can predict, yeah, there can be a pentagon, right? So for that method we use, right now we are using chain approx none, so it is giving us all the points. But if we use chain approx simple, so, and if I now run it, now this time if you see, it is not taking all the points, okay, 157, 152, 151, okay, means it sometimes creates some kind of a kind of a gap between them. It does not accept all the points, because right now we are talking of this kind of a shape. We are talking about these kinds of shapes, so yeah, most of the times all the points are required, because you are running in a circle, or it is also some kinds not circle, point ends over here, then it moves like this, then it is covering like this. So it is not accepting all the points. These arrays are way smaller than those arrays, so it's our choice. When we are working with some kind of shapes, then we use this chain approx simple, and we are working with a random kind of designs which are like irregular shapes, okay, then we use chain approx none. Depends your choice, from which thing you are feeling more comfortable to work with. So this is all about contours right now. Okay, now this is all the basic stuff in the contours. Okay, you now suppose, now this was our image. Okay, right now there are some contours, don't worry about it. This is our image. Suppose we want a contour around only the red image. We don't want a contour anywhere else in our whole program. How are we gonna do it? Think about it. We want only on red color or green color or blue color or maybe around the black colors only. Nowhere else we want the contours. So for which there is a method of mask creating. We create a mask of the red image and then we apply contour on that mask. That's how we can create a contour around the around this red color. So let's apply this method. I'm gonna show you how we can do this. Okay, so I'm gonna just remove all of this stuff. And to create mask, we need to find the means we need to have a good quality or good accuracy of about that color. And to get a good accuracy, we always work with not the grayscale or BGR or RGB method. We work with the HSV method. So I'm gonna just convert here it into an HSV. Okay, HSV is a hue saturation value. Its full form is, and the HSV basically HSV format is basically how we see an image with our eyes. The colors that we see through our eyes, it gives us that much accuracy. So that's why we use HSV method over here to create our mask. Now HSV for the red color now. Further videos I will explain how this HSV concept works really. But let's say, let just bear with me. Now what happens in the HSV is np.array. We're gonna create an array of it. Okay, and in this we are gonna give it index of HSV values. For the red, basically it's 0, 70, 70. Okay, up to, I'm gonna give upper R is equals to np.array. Okay, it goes from 0 to 10, and here I'm gonna give it 255, 255. Now these upper values and the lower values of the red, I have tested it and find out those values. So same way you also have to work with there are lots of HSV calculator tools over the internet. You can work with them and find out the HSV color for any color, HSV values for any color. Okay, now I'm gonna create a mask for it. So mask1 is equal to cv2 dot with the help of inRange method, and I'm gonna give it first variable as image comma lr comma ur, upper red comma lower red. Okay, now red color, the thing about red color is that it has two lowers and two upper images. Okay, it lies on the both sides at the ending point of the both side of the color graph. So again the second LR is second mask I'm gonna generate for the red color. Now it lies from basically I could say 170 again 70 70. Now the upper R will be np.array 180 255 255. Okay, now again I'm gonna generate a mask. It will be mask2 is equals to cv2 dot inRange image comma lr comma ur. Okay, now I'm gonna just add these two masks and name it mask is equal to mask1 plus mask2. Okay, so I have added these two masks. Now I'm gonna apply this contour on the mask only. Okay, just I'm gonna change the name of the image from here and it's mask. Rest, I think everything should be same. I'm gonna make it to none. And I'm gonna convert it into a tree or the list. Go with a tree. Okay, I think that's all about it. Okay, let's try it. Okay, name UR is not defined. Okay, it should be okay. There is UP written over here. It should be UR. Right. Sorry. CV2 has no attribute inRange. Capital R. Yeah. Now you see it has only detected the R color around that image. Okay, it is not taking any color. In fact, when I'm using right now the cv2.retrieval tree method over here, but it is not accepting any. It is only grabbing the R color out of that image. Okay, same way you can while doing a live, use your webcam, do a live something, and you put some kind of a color mask. Okay, like you want to find a color of your t-shirt, you want to create a border around your t-shirt, okay, or border around your face. So you can give it a color, your color HSV values, and it will draw contour around your image, on around your face, around your t-shirt. So that's a classic thing about it is. Now the major thing that we'll see it later in the video, I will work with object detection, and there I will show you how contours can really be helpful in detecting the objects. Okay, so this is all in the contours, and even if you see the array around it is, this is the array, a single array. Okay, it has only found one contour. Okay, this is all in the contours right now. Okay, so practice it. Okay, try with the canny and the threshold. Okay, it canny and threshold, there depends on what kind of a working you are doing. Okay, I told you, when you are really focused on edges, you work with a canny, and threshold is basically to little bit clean out the images and help it detecting the edges very clearly. So that's why we use threshold. And this is a mask concept. Okay, only for red we need to create two masks. If we are working on any other color, we don't need two masks, only one mask is accurate, is to work with. Okay, I will also I tell you how how I come up with these HSV values or the HSV methods. This complete method I will explain later in some video later in the course. Okay, so this is all in the contours. See you in the next video.